So, dear students, as we have seen about the decision tree theory part, now we will go for the coding part so that you will understand very clearly about how to calculate the performance using the decision tree, right? Okay, so for that, first I have to import the library in which first a NumPy, that is the numerical Python, and then pandas for the data frame, and then we have to in which sklan, in which I'm going to import only the test and the train split. Okay, so we are making the data set into test and training. I have to split it. Okay, so 75, 25 or 70, 30 percentage. Likewise, I have to divide. Okay, how much I can take it as a training sample and then test sample. With that, I can find the actual, and then only I can find the predicted value as right. So that's why I this particular function I have to just import from sklearn. Okay, sklearn dot model selection, and then decision tree classifier. If you want to run the decision tree algorithm, okay, so I have to import this. So in which how we calculated through entropy, all that thing. Okay, so very easy to call the function to run the thing, and then just we can ask to plot it. So for that, I have to give confusion matrix. Confusion matrix, as you know, we can see like in the C in KNN, true positive, true negative, and then false positive and false negative. With that value, we will find the confusion matrix, right? So we can also calculate the accuracy based upon the formula, right? We will put it true positive and true negative addition in the numerator, and all the other four values we will put it in the denominator and find the accuracy, right? So that for that I have to import all these functions, not only confusion matrix but also accuracy score, precision, recall, F1 score, ROC curve. Okay, so all these things that will be useful for the machine learning, different algorithm. For that, I can import all these performance metrics. Okay, and then standard scalar is the next function I'm using for pre-processing. Okay, so for that I have to import the standard scalar for okay pre-processing the information, because sometimes age, if I depend upon the application, if I want to normalize, so that is the time I have to go for pre-processing. Okay, and then plot tree for tree plot. Okay, completely the decision tree to be plot. I can just call the function plot tree, and then as PLT, that is with performance, if I want to after measuring to plot the decision tree algorithm, I can use it. Okay, for that I have to use PLT. So for this first, I'm going to CSV file, I'm going to read it. That is social network ads, in which what are the columns which we have? We have age, estimated salary. Okay, that means what is age? Age depend upon the age and estimated salary. We can say whether the particular person is going to purchase or not purchase. Got my point. So we can say age and estimated, we can say it as like independent variable, and we can see that purchased. Okay, so sorry, age and estimated salary, we can say it as like a dependent variable, and purchased or not purchased, we are going to give the result that we can call it as like an okay. So based upon this, okay, we can see, right? So so that is how we can see all these. We can take it as like X, and then Y, we can take it as like a whether we are going to purchase or not purchase. Okay, so we can see Y is purchased. Okay, so that's why we can say this is dependent. Based upon these particular value, we can go for whether we are going to purchase or not purchase. That's why we can say this is dependent, and these are all independent variables. Okay, after doing this, I have to split, okay, the training and test data. Okay, so we have X train, that is training data set input, and then Y train, we have Y train, that is training data set output, and then we can say X test, that is X test means we can say testing data set input, and then Y test means testing data set output. Okay, so that is how we are having these four different functions in which we are going to give the result as the actual value. Okay, and then we are going to calculate the predicted value. So for that, I have to use this particular function train test split, in which I have to give the ratio. Okay, how many percentage will be the training and how many percentage will be the test. Okay, so here I'm giving test size is 25%. That's why I'm giving 0.25 and the remaining 0.75. That is, we can tell it as like a training size. Okay. So that is how we are splitting it out. Okay, so after splitting it out, I'm going for feature scaling. As I told you, standard scalar, which is used for so feature scaling. Y means sometimes age is a low integer value. And if you consider salary, that is the big integer value. We have to normalize it. Otherwise, we cannot have the accurate result. So that's why we are going for feature scaling. Okay, so two values only we are going to compare. One is age and the another one is salary. So both are integer value. And we can see the variation in the limit is high. So that's why we have to go for normalization in order to improve the accuracy. Got it? So I have to call the function standard scalar. And after that, what I have to do is after doing this, I have to go for decision that is a scalar dot fit. Okay, scalar dot fit transform, in which I have to give the x train and x test. So what are the values which is splitted for x train? Okay, given that as an input, all that thing will be given, because all that thing only we will call it as like a we can call it as like training. Okay, so that's why we can say that X train that is 75% of the input. For that, I have to give it into scalar dot fit for normalizing the value. Okay, and then I have to give X test also, in which also we are having age and salary. That also I have to give to scalar dot transform. When I give like this, then only this all the values which is coming under the X test will be normalized. Okay, so that the accuracy will be improved. So feature scaling will be done. And after that, I have to call this particular function, that is a decision tree classifier, because in which I'm going to use the criterion as entropy. Okay, so as you know, entropy, that is from sklearn library. Okay, the decision tree classifier model will be built. And I'm giving this, then only this model only will be built. Mainly it is based on the entropy mathematical measure. Okay, so that is the thing we are actually doing here. And after this, I have to give the X train and Y train as classified dot fit. When I'm giving this particular value, then only I can get this actual value. Okay. So here I'm going to predict on the test set. So that's why I'm giving this X test as an okay. I have to pass on that particular attribute into the classified dot predict. That I have to put it into the Y pred. So now I will have Y test and Y pred. Okay, so this is based upon the result of the training samples, and this that is the actual value. And then Y pred, I'm going to predict the thing. Okay, so when I'm going to give the confusion matrix of it, so that is the time I will get the complete value of it. When I'm going to give this, I will get the complete thing of false, true positive, true negative, and then false positive, okay, and false negative. All the values I will get, okay, when I'm going to give this particular statement, confusion matrix of Y test, in which the actual value and then predicted value, that is Y predict, right? And then I have to calculate the performance metrics based upon this confusion matrix, that is accuracy, precision, recall, F1. Okay, based upon this Y test and Y pred, Y test and Y pred, Y test and Y pred. So same attributes only I'm going to pass for each and every function. Very simple, isn't it? So I'm not going to give any formula inside, but all that are predefined functions. So these are all the things for the performance metrics, and similarly specificity. Also, I have to calculate ROC curve and the AUC. All these are the performance evaluation in the machine learning model. Okay, so when we see all the type of machine learning, that is the time you will know about all this variety of performance metric why we are using here, right? Okay, and then finally, how we are going to format is, we are going to print the confusion matrix first, and then accuracy, precision, recall, specificity, F1 score, and AUC score. Okay, so confusion matrix, this is how I am getting. and then accuracy based upon the true positive, true negative, and true positive, true negative, false positive, and false negative. I'm getting the accuracy value, putting in the numerator and denominator, and then finally precision, recall, okay, specificity, F1 score, and AUC score. I'm getting the complete performance based upon the decision tree, right? Okay. So this is regarding how I'm going to in a decision tree table format. Okay, so just I'm giving like plot tree. Okay, plot tree is a function I have to give, in which I have to pass on the classifier featured names, in which I have to give age, estimated salary. Okay, that is the column. Okay, so that is the thing I'm doing, giving it as a feature names, and then class name, not purchase and purchase. That is the two variation in the class names, right? And then field equal to true. Okay, so that is we are giving in a colored format. So we can clearly see this is the input just, and I'm giving plot dot show. It is finding the which one is the root node and which is the leaf node. Okay, so which is the left and right, and then finally up to the leaf node in which there is no further classification. So clearly it is showing the tree. Okay, so sometimes the question may be asked based upon the depth of the tree. It will be asked to calculate based upon the depth of the tree. We will ask to calculate sometimes uh, the performance. Okay, so that is the time what we have to do is depth equal to 3 comma 5 comma 7. If the depth of the tree is either if it is 3 or 5 or 7. Okay, so that is the time we are just giving in the for loop, and all the other thing will be the same. Splitting the training and the test data, and then going for the prediction YPRED, okay, and then going for confusion matrix calculation, okay, and then the other performance metrics, and finally making the result out of it. When you run the function, you will give the very clear performance metric if you are taking the depth of 3 and the depth of 5 and depth of 7. Likewise, we can divide and show based upon the depth how the performance metrics is, right? So this is how we are doing it. Okay, so kindly see the both the video, then easily you will clearly get the result. Okay, both that is theory part also, then easily you will understand it. Okay, so I hope you understood the concept. Okay, right. Thank you.